Hey guys, it's Roya, and before I go into the solution for the previous video's practice problem, I want to quickly go over force diagrams and static equilibrium. So here, if we were to imagine, uh, actually, if we just take the practice problem from before, where we have a ball hanging from two strings, one at 30 degrees, or actually this one was at 60 degrees, and this one was at 30 degrees, then we can draw a force diagram by basically drawing a dot to represent the ball and then drawing all the forces acting upon it. Now think of the forces in an xy plane. First there's the force of gravity, and it acts straight downward. And if we were to make these a little bit thicker, maybe it's easier to see. So this is the force due to gravity, and W equals mg. Now, there are two other forces acting upon the ball, and we know about normal force, but there's no normal force here. There are two types of tension. So here's tension 1, and here's tension 2. And here we have an angle of 60 degrees, and here we have tension 2, an angle of 30 degrees. Now, since this ball isn't moving, that means there's no net acceleration. So, if F equals ma and a equals 0, then F equals 0. Now, as we see here, the forces on this ball do not equal 0. So why do we say F equals 0? Well, here we're talking about net force, which is the total force in any direction, x or y, equals 0. So we can decompose these two tension vectors into x and y components. If we decompose them here, we have one vertical and one horizontal from this, and we have one vertical and one horizontal from this. And the verticals might not be equal. In fact, they aren't equal. But as we see, the only two forces acting in the x direction are from the tension, and since net force of F of x equals 0, then these two have to be equal. So that means that T1 in the x direction equals T2 in the x direction. Now let's look at the vertical forces. We have mg here, and we have the two vertical forces from the tensions here. Now, since the net force of y equals 0, then we know that mg equals T1y plus T2y. Now with these two system of equations, then we can solve for the forces that are acting upon the ball. The important thing to remember here is that in static equilibrium, the x's cancel out and the y's cancel out.